My name is Saif Alomari. I'm from Jordan. I joined the University of Lisbon in Portugal as an early stage researcher in the TeraApps project. My research is mainly focused on resonant tunneling diode optoelectronic transmitters and receivers, and today I would like to give you a brief about my work. In simple terms, my project focuses on using resonant tunneling diodes with photodetectors in order to produce fast and highly sensitive detectors at telecommunications wavelengths, namely 1310 and 1550 nanometers. So, what does all of that mean? I begin by explaining what a photodetector is. A photodetector is simply a piece of material, usually made out of a semiconductor, which is able to detect light, be that light visible or invisible. So when we shine light on a piece of semiconductor, charges begin to move and we detect an electrical signal at the output. Photodetectors are an integral part of a lot of gadgets that we use every day, from IR sensors in our mobile phones, video cameras, fiber optic communications, and nowadays LiDAR for self-driving cars. The second part is related to resonant tunneling diodes, or RTDs for short. An RTD is a quantum mechanical device that utilizes a phenomenon known as resonant tunneling to transport charges. Thanks to this charge transport mechanisms, RTDs are considered as the fastest purely electronic devices till date. RTDs do show some other advantages, like being simple to fabricate and having built-in amplification capabilities. So, what exactly are we trying to do? We are trying to make a new device by integrating a photodetector with a resonant tunneling diode in a single device known as resonant tunneling diode photodetector, or RTD-PD for short. We want to design RTD-PDs that are able to operate at very high speeds, up to 10 gigahertz, and they should be highly sensitive to low light conditions to a point where they can detect light from single photons. So, one might ask, don't we already have good enough photodetectors? Well, photodetectors based on current day technologies will not be able to cope with the demand of emerging technologies such as self-driving cars, 5G communication networks, AI, and optical computing. Therefore, new devices based on new technologies, which are faster, cheaper, and more sensitive, are a necessity. And RTD-PDs can be the answer to such challenges. Now, what are we doing at the University of Lisbon? Our workflow can be summarized in 3 steps: design, fabricate, and test. In the design phase, we design RTD-PD devices using various materials and layers. These designs are then sent to our partners at the University of Glasgow to be fabricated on chips using state-of-the-art nanofabrication facility. Then the fabricated devices are shipped back to us for characterization and testing. According to the results, we modify the design and try new material systems in order to get better performing devices. Now, how will these devices affect next generation technologies? Well, when working on devices at the physical level, the applications are quite vast. They range from astronomy to military and defense, 5G communications, artificial intelligence, neuromorphic computing, and photonic integrated circuits. Photonic integrated circuits is of a great importance to us, and we are partnering with one of our partners in the industry, VLC Photonics, in order to find commercial uses for this device in current day technologies. Thank you very much for listening.